Here's an example. We are given the joint PMF of a random vector x, and well, we have x1 and x2 components, so this is in fact a two-dimensional random vector. Okay, so this is a vector of x1 and x2. Okay, and the joint PMF is given to us. If you look closely, point 24, point 16, point 18, point 12, point 18, point 12, if you add them all up, you get 1 as expected, and none of them obviously is negative. So this is really a joint PMF. So what does it mean? First of all, let's understand what this means. Now, for a PMF, in case of random variables, if you remember, that gave me probability masses, like let's say 0.25, 0.25, 0.5, 1, 2, 3, let's say. So this is a PMF of a discrete random variable, and that random variable taking the value of 1 has probability 1 over 4. Taking the value 2 has probability 1 over 4, and that take the value 3 has 1/2 probability. The same goes here. The only difference is we have now two components. So you see here, this point here is x1 equals 0 and x2 equals 2. Okay, so 0.16, this is the probability that x1 takes the value of 0 and x2 takes the value of 2. Okay, so this is the joint PMF evaluated at the point 0, 2. Okay, and this one, this is the probability that x1 takes the value 0 and x2 takes the value 5. And this one, 0.12. This is the probability that the random variable x1 takes the value 4 and random variable x2 takes the value 2. Or you can see this as the probability that the random vector x takes the vector of takes the value of the vector 4, 2. Okay, that's the same thing. Now, when you look at the probabilities here, the events, this is the probability that x1 exceeds 3, strict inequality, and x2 is less than 4, again strict inequality. So you should just look for the points or the vectors in the space that satisfy this event. So x1 greater than 3 is to the right of this line, and x2 less than 4 is this side. So the only point is this one here in the sample space. So this event is directly equal to the joint PMF evaluated at point 4 and 2, which gives me 0.12. Okay, and the next one, the probability that x1 times x2 is greater than or equal to 5. Now I have to look at each of these values to understand which of them, which ones satisfy this event. Okay, so obviously when x1 is 0, these are out. When x1 is 1, I just have this 5 here. So 5, 1 satisfies this. X1 is 1 and x2 is 5. And when I have x1 equal to 4, both of them, x2 being equal to 2 and 5, satisfy this event. Therefore, you have to add these three probabilities, these three PMF values. Okay, 1.5 is here, so that is 0.18, and that is 0.18. 4.2 is here, 0.12, and 4.5 is 0.18. If you add them up, you get the probability as 0.48. Okay, and finally, you have the probability that x1 minus x2 absolute value exceeds 1. Okay, so here we have just apart from this point 1, 2, and 4, 5, all the others are more than 1 apart. So that is 0, 2, 0, 5. They are 2 apart and 5 apart. And 1, 5 is 4 apart. 4, 2 is 2 apart. Okay, and therefore all of them are in this event. But then instead of doing that, it's easier to consider the complement of this event. Therefore, I just compute this probability by 1 minus the PMF value at 1, 2 minus the PMF value at 4, 5, which does not satisfy the event. Okay, so at 1, 2 you get 0.12, at 4, 5 you get 0.18, subtract from 1 you get 0.7 as this probability.